Assalamu alaikum guys, how are you? In this video we are going to see how to integrate this MSRC522 RFID module with the Arduino and use it to read RFID tags. So this is an MFRC522 RFID module. It works on 13.56 megahertz of frequency and it uses SPI protocol to communicate with the Arduino Uno. So now let's jump into programming. We'll see how to which pin connect to which pin of the Arduino, and we will also see a simple example of dumping the info of RFID tags into the serial monitor. These are the RFID tags. This is RFID 13.56 megahertz card which we will be reading. These are the RFID key flops. You get a single key flop and a key card along with when you buy the RFID module. If you want to buy additional cards, you can just make sure you buy the ones which are supported by this module. It has happened to me two times that I bought the wrong frequency card. I think 130 kilohertz, something similar to that, cards which are not supported by this module. The Arduino IDE, before just connecting the pins and everything, what we have to do is we have to install the MFRC library. So there are two ways to do that. One of them is you can go to file, and I think it was in sketch. Yeah, okay. You have to go to sketch, include library, then click on manage library. You have to search here for MFRC 522. Okay, this is the library which we need, MFRC 522 by GitHub community. Since I have already installed it, so it is showing remove. And the second way to install the library is you have to go to the official GitHub page. I will leave the link in the description and download the zip file. Let's download it. It's done. Let me open it. Okay, so this is the zip file for the MFRC library. I have previously downloaded one. Then you have to go to then what you can do is go to sketch, include library, add.zip library, and simply select the zip folder and click open. It should add the library. After installing the library, we have to go to files, example, come all the way down. You should see MFRC522. These are the example codes or programs which you can open, run and see and upload. For now we are going to choose this dump info one. I'm going to click it, wait for it to load. Hello. Okay, it has been loaded. This is basically the code which we'll be uploading to the Arduino Uno. So for connecting the pins, you can see here which pin is supposed to be connected to which pin of the Arduino Uno and MFRC module or RFID module. So for Arduino Uno, these are the digital pin 9, 10, 11, 12. 9 is for RST of the MFRC, 10 is for SDA, 11 is for MOSI, MISO, SCK. One thing which you have to remember is you can change the 9 and 10 pin, RST and SDA pin. You define the pin number here for Arduino Uno. You can change these two pin, but all the other pin like MOSI, MISO, SCK are predefined. You cannot change them. So for now we are going to go to the connections to connect the MFRC to Arduino Uno. Oh, there are three more pins actually, which we need to look at. For the one is the VCC 3.3 volt, which is to use to power the module. Second is GND ground, and the last is IRQ. We are not going to use the IRQ. We don't need it. As you can see here in the module pins, there is no IRQ pin which corresponds to any Arduino Uno pin. So now we are going to connect the Arduino Uno to module. Okay, now we are going to connect the module to the Uno. As you can see here, these are the pin names of the module. First is 3.3, then is RST, GND, then it is IRQ, MISO, MOSI, SCK, STA. This module uses SPI protocol. We will connect the 3.3 and GND to Uno's 3.3 and GND. As you can see here, there is a 3.3 volt, and below it there is GND. And we'll connect all the other pins from here from now. I have connected the pins. If you have any problem with the pin connection, or you didn't understand any of the connection, you can take reference from this photo, which clearly shows the connection of the pins. Now I'm going to plug in the Uno. Okay, I have plugged in the Arduino, and you can see the red light here in the module, which is showing that the module has power. Be careful to not connect the module to 5 volt pin, as it will destroy the module. Now we are going to the Arduino IDE. So we are in the IDE. Now we are going to look at the code. So these two include statement basically include the library, MFRC library, and SPI protocol library, through which the module and Arduino communicate with each other. This actually defines our pin, the RST pin, RST pin, STA pin. Here we are actually creating an instance, or basically you can say an object of MFRC522. In the setup method, we are beginning the serial communication with the PC. Here we are initiating the SPI communication, and this is here we are actually initiating the MFRC522 what we say object. You can read the comments. These are very detailed. There's a delay. This actually shows the detail of the what we say tag or the card which we will be reading. Okay, so in the loop. Okay, so these two functions basically check if there is no card in the proximity or near the reader which it can't read. So it should just return or close the function. While this line here, MFRC522.PIAC dump to serial, this thing actually dumps the whole data of the card on the serial monitor. Now I'm going to select the board to be Uno. Board has been changed, and the port to okay. Arduino Uno has been selected, and the correct port has been selected. I'm going to upload the code. The code has been uploaded. Now I'm going to bring RFID tag near the module or the reader, and I will show you the output. First, let me just open the serial monitor here. The shortcut is Control Shift M, or you can go to Tools and Serial Monitor. This is basically showing the firmware of the module, and this is actually this line here. Here you can see MFRC522 version to serial, the firmware version. Now we are going to bring the RFID tag near the reader to read it. Okay, I have this key flop, RFID key flop. Now I'm going to put it near the module, and you can see here the data is, it is reading all the data. We are done. Now I'm going to go through this whole data, how the structure is actually stored. These tags and these key flops, they have about 1 kilobyte of data storage inside them. Okay, so this is all the info which it dumped from the tag. I'm going to just increase this side. Okay, so the 1 KB storage inside the tag is divided into 16 sectors from 0 to 15. As you can see here, it starts from 0 and goes all the way up to 15. These sectors are further divided into blocks. A sector has 4 blocks. For example, if we talk about the sector number 15, it has block number 60, 61, 62, 63, and the first block is 0. The sector 0, block 0, here as you can see, sector 0, block 0. Oh, the block has a block has a 16 bytes of storage, but unfortunately the whole 1 KB of storage is not accessible to us. In the sector 0, block 0, this is the manufacturer information stored here. We are not supposed to change it, as it could render our whole tag unreadable or unusable. It could lock it up, encrypt it. And the last block of every sector is called trailing block. For the sector number, let's suppose sector number 1. In the sector number 1, the last block is the 7 one. This block is called trailing block. It contains 2 keys and access bits of this whole sector. Keys are basically used to authenticate whether we have the read and write permission. We will go into the detail in later video. And access bits are also how we can access, whether we can access the what we say, the whole block or not, can we read it or not. These types of things are stored in the trailing block of a sector. If we go up, we can see here the card UID. This is actually the unique identification of the card. PICC type, MIFARE. Here we can see the 1 KB. This card sec is basically what we say, manufacturer code and product type. These are basically the access bits. As you can see, 001. We'll go into the detail in another video. So this is how the card is structured. As you can see, from 0 to 15, these are bytes. Total of 16 bytes in each block. If you sum all of these up, you will get about 1 KB of total storage. You can also find some cards with 4 KB of storage. It actually depends on your need, but for this project or for this tutorial, we will be using these 1 KB cards. Okay, thank you guys for watching. I hope you liked this video. Please subscribe and like, and do comment if you have any questions. Thank you.